Good afternoon, students. So we'll start with today's class. So last time I told you all about three concepts or three terms. One was internal resistance, one was terminal potential, and third one was EMF. Okay, I told you all the difference between EMF and terminal potential or terminal voltage. Please don't forget this thing. It's very, very important. EMF is denoted as E. Terminal potential is denoted as V. Both are voltages. Both are voltages. Okay. But one is called as EMF, another one is called as terminal potential or terminal voltage. Now, what is the difference between the two? Briefly, I will tell you all. When you go to the market, get a battery from the market. त्या बॅटरीचेर एक व्हॅल्यू बरयल्लो आसतलो, like 12 volts or say 13 volts or 14 volts, whatever it is. You have not yet used that battery. You are still in the market with that battery in your hand. You are reading the specifications given on it. Suppose if you see some value written on it, say the voltage is 12 volt. That means it is claiming that it is going to give you 12 volts. That battery is claiming that it is going to give you when you will use it in the circuit or when you will use it for any purpose, like a remote, TV remote asta, battery for use jata, any example you can take. So wherever you use that battery, the value which is written on it, suppose it is written say 12 volts. That means the battery is claiming that I'm going to give you 12 volts, okay, wherever you are going to use it. But as I told you all, when you try to use it, when you get that battery at home, you put it in the connect it to a circuit. Connect it to a circuit means what? Put it in a remote battery or for any purpose wherever you are using that battery. Okay. When you start using it, you always see that you don't get 12 volts, but you get lesser than this value. Lesser than this value. हेजी परस कमी मेळटा तुमका value. Okay, you will get some say 8 volts or 9 volts or say 7 volts or whatever it is. But 12 volts मेळचो ना तुमका. जो claim करता तो मेळना. तेजान कमी मेळटा. Now, why do you get lesser when you try to connect it to a circuit? Because, okay, before that, whatever lesser value you get, lesser value than 12 volts. Say, for example, 8 volts you get. These 8 volts, what actually you are getting is nothing but terminal voltage. Battery is claiming that it will give you 12 volts, but when you get it home and try to use it in the circuit or use it in the remote, you will not get 12 volts, you will get lesser value. That lesser value, actual value what you are getting is your terminal voltage or terminal potential. Now, why are you getting lesser voltage? Because jenna तुम्ही this particular battery, okay, this battery say, ही battery जी आसा जेन्ना तुम्ही use करतात, use करप म्हणल्यार कितें तितूंतल्यान current flow जावपाक लागता. When you use this battery, that means current starts flowing through it or current is generated through it. जेन्ना current generate जाता, या battery भितर electrons flow जाता inside the electrolyte. Battery consists of three things. दोन electrodes येतात एका, these are the two electrodes, and inside it there is electrolyte, liquid, solution असता, chemical solution. Okay, through that chemical solution also electrons flow. Exactly what happens, which I have told you last time, so I'm not going in detail. So basically what I'm trying to say, it is claiming that it will give you 12 volts, but you are getting 8 volts. So जे कमी झाला, 12 minus 8 is 4. 4 volt खंयतरी गायब झालो. Lost. 4 volt is lost. It is not used anywhere. Where has it gone? That 4 volts 12 volt it is claiming. You are getting 8 volts. How much is left? 4 volts. So 4 volt is lost. And where is it lost? This 4 volts is taken when it is connected in the circuit. This 4 volt is taken by the battery itself to work. इथे याद दिला थोडं. And who, or in other words, the battery is eating up this 4 volt. And how is it eating up the 4 volt? By using its internal resistance. Internal resistance नुसार या battery भितरलो तो हो 4 volts खतम. So whenever you get a battery from the market, the battery says that I will give you this value. Okay, I will give you this value, but you won't get that particular value. The reason is because battery जेव्हा connect करतात त्यांना battery स्वतःसाठी थोडी voltage घेतात आणि remaining voltage is given to the to you or to the circuit. So it will not give you the full voltage which the battery is claiming. Some voltage it will keep it for itself, like 4 volt it has kept for itself, kept for the internal resistance, and remaining जितने उड़ता तितकी काढून ते for whatever purpose you are using, it gives it over. Is the concept clear to everyone? Yes. EMF, terminal potential, internal resistance is clear to everyone. Please reply.
Yes, teacher.
Okay.
Yes, sure.
Next we'll write down or next we'll study expression for internal resistance. Internal resistance also a formula also. That formula we are going to write down. Expression for internal resistance. Expression for internal resistance. Draw this. Small r is your internal resistance. Again, I'm repeating. Internal resistance is actually inside the battery. But सर्किटान दाखयता असताना आम्ही त्याका सारख्या बॅटरीच्या साइडीन दाखवप असतं. The representation that you show for internal resistance is exactly at the side of the battery. So small r केन्ना आयले जाल्यार याद दवरा, it is the internal resistance. And external resistance is always marked as capital. Meaning जो भायल्यांच्यान resistance लायता. This is inside the battery. खंयची एक battery consider करात, त्या battery भितर जो resistance असतलो that is your internal resistance. आणि एक resistor suppose भायल्यांच्यान हाडून तू connect करता that is your external resistance. Okay. So write down. Okay, this is the battery which is of EMF E. Here, this is the battery which is of EMF E. Meaning what? ही battery आता सध्याक तुवें हाडल्या बाजारांतल्यान मार्केटांतल्यान घेवन आयला. You have not yet connected it. Although you can see the connection, you can see here key is open. ही wire open आसा. Close केली की current pass जातलो. Open केली की current pass जावपाक जागो ना. There is no path for current to flow. हांगा येवन stop जातलो current. Current has to flow, right? It has to go from positive side and come towards the negative side. But here it is open. So current is not flowing right now. So write down when key is not pressed or when the key is open, write down like this. When the key is open, the potential difference, when the key is open, the potential difference across terminals of cell, when the key is open, the potential difference across terminals of cell is EMF E. You see, into bracket write E. I'll repeat, when key is open, the potential difference across terminals of cell is EMF into bracket write E. What does this mean? When key is open, which is more like saying the cell is not connected to the circuit yet. तुवें अजून सेल हाडून रिमोटान भितर घातलो ना. It is just like saying you are standing with the EMF battery in the market. Think it that way. Key is open means current is not flowing. Current flow जायना म्हणल्यार your battery is not connected. Your battery is still in your hand. You are looking at the battery. तेन्ना तेजी voltage कितली असता? What it is claiming. Please listen to this carefully. I am repeating again. When I say key is open means current is not flowing. Current flow जायना म्हणल्यार कितें? The battery is not yet connected to the circuit. Best way to say is key is open means battery is still in your hand. तेन्ना त्या बॅटरीचो potential कितलो आसतलो? It will be what it is claiming. तेजे जितली बरयल्ली आसतलो value, that will be the value, which is nothing but EMF E. First part is clear. What do you mean by key is open? Yes?
Yes, teacher.
So when key is open, the EMF, the potential difference will be nothing but the E. Now what will happen when the key is closed? Key is closed means you will connect this. Key is closed. अशी close केली. Close करप म्हणल्यार current will start flowing. Current flow जावपा लागलो की कितें जाता? Resistance जो आसा तो त्या बॅटरीचो थोडो voltage आपल्याक दवरतलो, internal resistance. It will keep some voltage from that battery to itself and it will give remaining amount of the voltage to this particular circuit. So write down, when the key is pressed, the current through the circuit is, when the key is pressed, the current through the circuit is, that means from positive terminal current starts flowing, it will come back to the negative terminal. Also return येवपाकूच जाय. Please don't forget. Current जो आसा तो positive साइडीच्यान भायर सरता तेन्ना negative साइडीच्यान परत return पावपाकूच जाय. Compulsorily it has to come back to the negative side. It is just like saying charges are moving out and they have to come back. Because I told you all, charges can never be created nor destroyed. It can only go from one point to another. So from where to where they are going? From higher potential to lower potential. So if they are moving out from higher potential, they have to go to lower potential. This positive is your, this bigger line is your positive line, which is higher potential. The smaller line is your negative line. It is nothing but lower potential. Okay. So this current is given as what? Now we know from Ohm's law, P is equal to IR from Ohm's law. Okay. So I will be equal to V by R. I will be equal to V by R. So what will be that current given as? What is V over here? Voltage किती दिले ना? E, EMF. So it will be E upon. Tell me how many resistors are there? You cannot just write R. You have to see how many resistors are present over here. So how many resistors we can see?
2.
There are 2 resistors. Correct? So one is small r, second one is capital R. So it will be R plus R. So this is the current flowing through the circuit when the key is pressed. The terminal potential difference. Now when key is pressed, what will be the terminal potential? Terminal potential difference. I have given you the formula last time. It is given as V is equal to E minus I. E minus I. I hope you all remember this formula. Last time I had given you. Terminal potential V is equal to EMF minus I into. From Ohm's law, we know that V is equal to IR. From Ohm's law, we know that V is equal to IR. Now you know the value of I. Substitute it here. So it will be V is equal to, then mark this as equation 1, this is 2. Substitute 2 in 1. Substitute 1 in 2. Substitute 1 in 2. So it will be V is equal to I is E upon R plus R into this. Or this R I can write further. So I value is E upon R plus R into this. Now this term I'll take this side. So finally what we are finding out, equation for R, internal resistance equation we are finding. So I'll take this denominator this side. So you will get V R plus R into ER. Now solve the bracket. So this will be VR plus VR is equal to ER. Now we want R, small r. So small r term I'll keep on one side, capital R term I'll take on the other side. So it will be VR is equal to ER minus VR. This VR term I have taken that term. So here you can take R common. You will get E minus V. And finally we want R, small r. So I'll keep R on one side. E minus V upon this V I have taken. Now I can solve it for the denominator if I want. So this will be E upon V minus V upon V. It will be 1. So this is the equation for internal resistance. Small r is equal to capital R into bracket E by V minus 1. E by V minus. This formula is used for numericals. So please don't forget this formula. Many a time students make mistake while writing capital R here. Please don't make that mistake. Internal resistance सदा small r denote चलता होता. External resistance सदा capital R denote चलता. So please don't jumble it up. Internal resistance means small r. External resistance means capital R. Next, write down grouping of cells. Grouping of cells. Grouping of cells. Okay. Till now you have seen capacitors connected in series, capacitors connected in parallel. Next, we saw resistors connected in series, resistors connected in parallel. But as I have told you all, the combination of resistors is not there for you all for the syllabus. Okay, derivation we none, neither you will get any numericals on that. But those formulas can be used further in some other topic. So, फक्त formulas हमें तुमका दिले. Third thing is grouping of cells. That means cells connected in series and cells connected in parallel. Now these derivations are there for you all. Okay, and the formulas are not related or similar to what we have had in capacitor or resistor. These are kind of different formulas. So let us see that. So first one, right? Capacitor, sorry, cells in parallel, cells in series, cells in series. Cells in series. First one, cells in it is nothing but batteries connected in series. Don't battery suppose series and connect करत जाल्यार series जाता. Okay, that is what we are going to study. So draw the diagram. Okay. So two cells I have, cell E1 and E2. Both are connected in series. Series म्हटल्यार कशें एका फाटल्यान दुसरो जेन्ना connect करतात तेन्ना आमी series म्हणटा. Like you are holding hand. एक line करून you all are holding hands together. Okay, तुझो हात आनी कोण धरता, next hand someone else is holding. That is called as series. So I have two cells here. Now here one thing to note is you have to take care of the what is that negative and positive potential. Here you can see positive potential of the second battery is connected to negative potential of the first battery. Because if it is ulta, then sign changes. Okay, so you have to note that as well. So positive potential is connected to negative potential of the first battery. Now here, one thing will remain same. As we know, when the resistors were connected in series, current was remaining same. जेन्ना resistors सिरीसान connect जाताले, दोन resistors, okay, it was connected to some battery voltage. I told you all here there will be three quantities: voltage, resistance, and current. Resistance we know R1, R2, but when it is in series, current flowing through R1 will also be I1, sorry I, and current flowing through R2 will also be I. Whereas when it is in series, voltage across two will change. Here it will be V1 and V2. Like in capacitance, how when the two capacitors were connected in series, the charge across two capacitors were remaining same. Similarly, for resistors, current will remain same. For cell, current will remain same. Okay. So in series, first thing what it is? Current I through both cells will remain same. Whereas voltage will change. Or terminal. Voltage is what here? Terminal potential. Will voltage will change. Or terminal potential will change. Okay. So ह्या सेलांतल्यान करंट सदांच पॉझिटिव्ह इलेक्ट्रोडांतल्यान भायर सरता. So ह्या हितूंतल्यान I भायर सरलो जाल्यार from here also it will be I. Here also it will be. Please don't forget. through both the cells, current will be same because they are connected in series. Okay. So ekatlan, suppose we are marking it as I. We don't know how much is the value. General equation here, derivation baneta. So from E2 also it will be 1. But voltage across this one and voltage across this one is going to change. Let us see how much. Okay. So first we'll find out voltage across E1. Voltage across or terminal potential. Anything you can write. Voltage across E1. Voltage across E1 means it will be voltage across these 2 points AB because AB च्या भितर E1 असा. I want to find like this. V1 here and voltage across V2. V2 is V2. Or I can write it as, instead of writing V1, I can write it as AB and this I can write as B. Why? Because see, E1 खंय आसा A आणि B च्या मध्ये आसा. E2 खंय आसा B आणि C च्या मध्ये आसा. Okay. So voltage across E1 will be nothing but VAB. Voltage across V1, E1, sorry, this cell will be nothing but between these 2 points. So VA, which will be equal to, what is the formula for terminal potential? P is equal to E minus IR. This is the general formula. So can you tell me what will be the voltage across this one? E1, using that formula, VAB will be equal to what? Derivations are important. Can you hear me? Joella, can you hear me?
Yes, teacher.
Is the board clear now?
Teacher.
Okay. So we were talking about cells connected in series. So I'm finding out, like for example, this was U for a cell E. हांगा cella भितर internal resistance आशिल्लो R and current flowing through it was I. Okay. So this was V is equal to, now what is the potential across this cell after the current starts flowing? It was V is equal to E minus IR. It was general formula. Now I'm asking you, I have to find potential across or voltage across this cell, like how I have found here, and voltage across this cell. So first I'll find voltage across this cell. So voltage across this cell means this, where is this cell? It is between these 2 points. That means I can write it as VAB. I'm just naming it. Voltage across E1 is nothing but VAB. Here I have written just V because हांगा 2 points नाशिल्ले. आता हांगा 2 points आसा. So I'll write it as VAB. What it will be equal to? Use that formula and tell me. What will be it equal to? Krishna Kumar. Krishna Kumar. Are you there? Those who are not answering, I will remove you from the group or you remove you from the meeting. You cannot come here just to say present and just mark your attendance. Krishna Kumar. Sadika. Sadika. Can you hear me?
Yes, ma'am.
Okay, what will be the value? VAB will be equal to what? Just look at that formula and answer. So simple it is.
E1 minus I.
E1 minus C. You are finding out for this one, right? You are finding out for this one. So it will be E1 minus I into internal resistance will take it R1. Okay, हांगा एक resistor असेल of this cell R1 and हांगा एक असेल of this resistor it is R. First one झालो. Okay, VAB will be equal to E1 minus R1, which I can write as, see, potential AB is nothing but, in your second chapter we have studied, you can write it as potential A minus potential. If you remember, in the second chapter, potential जेन्ना आम्ही study करताली, we were writing potential from between 2 points, A and B, inside the electric field. We were writing it as VA minus V. So I have written it that VAG can be written as potential at this point minus potential at this. Now why we are writing it, that will come to know. Similarly, let us find out the voltage across heat. This voltage across heat. Okay. So what it will be? Voltage across E2 means what? These 2 points B and C. So it will be VBC will be equal to, which cell it is? E2. E2 minus IR. Current is same. Resistors has a different ascolo, has an internal resistance different. Which I can write as VB minus V. Okay. basically what are we doing here? दोन सेल जेन्ना सिरीसान कनेक्टेड असतात तेका आमी कंबाइन करून एक सेल करतात. So this diagram, after solving, it should be like across A and across at point C. हे दोन्ही पॉइंटाचे भितर दोन सेल्स असतात which are connected in series. After solving, you have to combine it and make a single cell, which will be called as E12. E1 and E2 combine करून आमका equivalent मेळपाक जाय and the internal resistance दोघांचो combine करून आमका R equivalent मेळपाक. This is what we want. So finally we want the value for E equivalent and R equivalent. It is nothing but we want the value across or potential across AC. So write down VAC will be equal to VA minus VC. We are finding out this, right? What is along AC? So VAC will be equal to VA minus VC. Now VA minus VC I can write as, this is some calculations you have to do. VA minus VB, VA minus VC plus VB minus VC. VA minus VB I can write as VA minus VB plus VB minus VC. Is this equation not equal to this one? Minus VB plus VB cancel out केले, हे दोन्ही cancel केले, जाल्यार किती उरले? VA minus VC. That is what we want. I am writing it this way because I can substitute these things over here and get the value for VA. Okay, so along A and C, it will be VA minus VC. VA minus VC I'll write as minus VB plus VC. I'm doing this so that I can substitute. So VA minus VB is what? E1 minus IR1, substitute it. So VAC will be equal to E1 minus IR1 plus VB minus VC is what? E2 minus IR. E2 minus IR. Now what I'll do, I'll keep E terms together because finally I want the equation in terms of E is equal to E minus I. Yeah, term on maka equation. This side I have B, this B. Now I want all E terms together. Hanga kitni E terms is ek or do. So all E terms I'll take together and IR terms I'll take together. So VAC will be E1 plus E2. E1 plus E2. Then which sign I want? Minus. So minus, what is next? IR. So what I can write it as? See, minus sign I have taken out. So it will be I R1 and here there is minus sign. So what I have to put here? Plus. Because minus into plus will be minus. See, the same terms I am writing here, but I am writing in terms of this equation. Because finally I want something in terms of this equation. So VAC will be E terms I'll write together because I want this. Suppose E terms are E1 and E2. So E1 plus E2. Or even if you don't write this bracket, if you think you will get confused. So E1 plus E2 ek barabar banele. Then next what we want? Negative. So negative sign. Next what we want? IR. So how many IR terms are here? There is one IR1 and there is another minus. This is minus IR1 minus IR. So what I will do? Negative I already barele. So IR1 I'll write. Now see, negative IR1, same value I'm getting. Now this term I have to put. If I put here same term, if I take and put it here, then what will happen? Minus into minus will be plus. Is it plus over here? No. So I have to put plus. So this I'll write as E1 plus E2 minus I take common. Now is it in this form? This form. Now if you talk about this, what would have been the equation for this one? PAC would have been E equivalent minus I R equivalent. Now compare equation 1 and equation 2. Compare equation 1 and compare equation 1 and this is equal to this one. Yes. E equivalent is equal to this one. So you can write E equivalent is equal to 1 plus. So we got one formula. When the cells are connected in series, equivalent cell will be just adding up all the cells. Okay. Then minus sign, I, R equivalent will be equal to what? R1 plus R2. So when they are connected in series, even their internal resistance you have to keep X. Is the derivation clear? Yes.
Yes, teacher.
See, mostly you all were not getting the derivation for the exam, this self derivation for the exam. But since I have told you all, yeah, this year from this chapter, many derivations have been removed. So hardly this is one of the derivation which is left. So you cannot skip it. Exam. Mostly you used to get the numericals on this. What is that? This particular concept. Okay, equivalent find out करपाला येताले R equivalent and cells are connected in C. Now one thing to note. Suppose second positive potential of second battery is connected to negative potential of first battery, then this is the answer or this is the equation. Now if suppose the diagram is like this. Negative of the first is connected to negative of the second. Okay. Or ulta asa. This is reverse. Negative of the first is connected. Now this is what? Negative of the first is connected to positive of the second. If negative of the first is connected to negative of the second, then E equivalent equation will be E1 minus E2. Please remember this. R equivalent will remain here. R equivalent will be R1 plus R. It will not change. Resistance minus Eugen. So please don't forget this. Many a times they ask this question. Sorry. If negative of the second is connected to negative of the first, then you will get a minus sign. If positive of the second is connected to negative of first, you will get a positive. Write down some points. If n identical cells, small n, if n identical cells if n identical cells म्हटलं त्यांचा EMF same असतो. You will not mark it as E1, E2, E3 and so on. It will be E every. If n identical cells, each of EMF E, capital E, if n identical cells, each of EMF E and internal resistance R are connected in series, then meaning the diagram will be like, okay, n types. So E, E, and everywhere internal resistance will be R. Then the equivalent EMF, E equivalent is given as n into, it is n times. N. E equivalent is given as n into same thing what I have given. हमको formula किती मिळालं ज्यांना दोन connect केले E1 plus E2, correct? Now if E1 and E2 were same, what you would have written 2 times E. If E1 was equal to E2, दोन्ही value same आशिल्ले. जाल्यार आमी किती बरयता आशिल्ले 2 times E. Okay? So n cells connected आसा, then we would have written n times and internal resistance and equivalent internal resistance will be n times R. Why? Because we keep on adding that R1, R2, R3 and so on. R equivalent will be equal to n times R. Therefore, the current flowing through the load is, what is the formula for I? Is V by R. So I will be, what will be V here? It will be E equivalent. Because after combining this, you will get a single battery, that is E equivalent, and resistance will be R equivalent. So voltage कितली आसांगा? E equivalent. Upon it is connected to a load, it is saying load. Load means it is connected to some external resistance. Please remember this. When it is said that it is connected to a load means it is connected to some external resistance. So it will be R plus R equal. I is equal to V by R. Voltage upon resistance in the full circuit. So how much is the voltage given? Equal. How much is the resistance? आमका दोन resistance, R equivalent and R. So E equivalent is equal to R upon R, internal resistance, equivalent internal resistance. Now substitute. This will be NE upon R plus NR. So this much is the current. Note down, I forget. Write down. If if NR, that is equivalent resistance, if NR or R equivalent is very less than external resistance R. If NR or R equivalent is very less than capital R, then I will be equal to, if this one is very less than this one, then this term we can ignore. So we'll get N E upon R. So I can write as N times E upon R. And what is E upon R? E or V is nothing but voltage. So E upon R is the current in the circuit. So it will be equal to N times circuit current. N times circuit current. It's not really very important, but they might ask some questions, numericals on this. So I'm just giving you all the formula. Series and current when the R equivalent is less than R. Internal resistance and load resistance अपरस कमी असता, then what will be the value of current? Second case, if NR or R equivalent is very greater than capital R. That is internal resistance suppose load resistance अपरस थोड़ा, external resistance अपरस थोड़ा. Then if this is the case, then this term we are going to ignore. So therefore I will be NE upon NR. From you, NE upon N. So NN cancels out, E by R. And this is called as, into bracket right, short circuited current obtained from one cell. I is equal to E by small r. Small r is this resistance of one cell. Short circuited current due to one cell. Short circuited current obtained from one cell or due to one. Next point, write down. Maximum current can be drawn from series combination of cells. Maximum current can be drawn from series combination of cells if external resistance is very large as compared to equivalent internal resistance. I'll repeat again. Maximum current can be drawn from series combination of cells. Please underline maximum current. If external resistance is very large as compared to equivalent internal resistance. So if capital R, this external resistance is very larger than equivalent internal resistance, then current will be maximum in series combination of cells. So तुमका maximum current suppose जाय जाल्यार आमका किती करचे पडटले सेल सिरीसान कनेक्ट केले आणि एक्सटर्नल रजिस्टर जो लायता तो ह्या इक्विव्हॅलंट रेजिस्टन्सा परस चड असतो पडतो. That last point is more important. Next, write down cells in parallel. Cells in parallel. Cells in parallel. And cells are connected in parallel. Okay. Take down the diagram first. Draw straight line. Okay. I'll mark this point as E1, point as E2, point as E2. These are my two cells E1, E2. They are connected in parallel. Okay. Now, after solving this, I should get what? I should get, after combining these two, I should get one single cell, which is along AC, will be my E equivalent. And here there will be a resistance, it will be R equivalent. Similarly, hang ek resistance is there, and here there is one R2, R. Internal resistance. So after solving this, I should get this. Okay. Now, when it is in parallel, I changes, current through both will change. It will not remain same. Okay, parallel combination and current changes. Whereas voltage across E1 and E2 will be. So hanga voltage and hanga voltage same. You don't have to mark it as V, whatever. V1, V2 mark karwachi garaj na. Both will be, here also it will be P, here also it will be. Let us see what is the current. Now you can see from positive terminal current starts flowing. So from E1 I'll mark the current as I1. From negative terminal the current, from positive terminal of this the current starts flowing from battery E2. So I'll mark it as I. Ata, I have not shown this that the circuit is connected somewhere. Also I had told you all that positive terminal atlan jenna I वयता त्यांना somehow it has to come back to negative term. Current जेन्ना पॉझिटिव्ह टर्मिनलांतल्यान भायर सरता तो नेगेटिव्ह त्याच बॅटरीच्या नेगेटिव्ह टर्मिनलाकडेन पावपाक जाय परत. Okay, so although I have not shown the connection over here, it will be connected somehow. So that हांगच्यान also येवन तो current परत हांगा परत. So I1 will come back. Similarly, somewhere from here it will come back over here. This is connected to something. I have not shown the connection because it is not required. It is logically you should know that if I1 is coming out from the positive terminal of this battery, then I1 should come back to the negative terminal of this battery. Similarly, if I2 is coming out from negative terminal of this, positive terminal of this battery, then I2 should come back to positive terminal of this battery. पंचानवे connections असलेले it will come. Okay. So there are two currents we can see through I1, E1 it is I1, through E2 it is I2. Voltage across both will remain same because it is parallel combination. Okay. So total current will be what? I1 plus I2. या जंक्शनाचेर हांगा हो I1 आणि हो I2 meet जाता and then it will pass here. So this will be I. Correct? See, I1 and I2 is meeting here. Like they are going like this. हांगा meet जाले. So like 2 ampere, 2 ampere. हांगा meet जाले. आता दोन्ही एक जावन एकूच पातान वयता. So कितले इतले 4 ampere. Okay, so I1, I2 meet here, and how much it is going? They add up because there is a junction here. They add up and single pathatlan they pass. Okay, assume it will be like connected somewhat like actually connected. So I will come from here to here. I know. I will be here. हांगा पावतरी परत split जाता. So split जातरी I1 knows that I have to go to E1. I2 knows I have to go to E1. Are you all understanding this? Yes. Please answer. Teresa, are you understanding?
Yes, teacher.
Rutvik? Tilak? Tilak?
Teacher.
Understanding, no?
Yes, teacher.
Okay. So, I will be I1 plus I2. Now, let us see the voltage across E1. The voltage, write down. Voltage across E1. Voltage across E1 will be what? As I told you all, voltage will remain same. So, I'll write it as V. So, V will be, formula is what? V is equal to E minus IR. So, voltage across E1 will be V is equal to E1 minus I1 R1. Because current is different, right? Hanga I1 is. So, it is I1 R1. From this, let us try to find out what is I1. Because finally, आमका किती करचे पडटले I1 आणि I2 हांगा substitute करून आमका I find out करपाक. Okay. So let us see what is I1. So if we want to find what is I1, take this term this side or take I1 R1 this side. So I'll take I1 R1 this side and I'll get E1 minus V. V term I got this side and for हे संज्ञा. So positive आशिल्लो हे संज्ञा हाडलो negative जालो. Negative आशिल्लो if I took it this side it will be positive. So from this I1 will be equal to E1 minus V upon R. We got the equation for I1 will be equal to E1 minus V upon R. Mark this as equation 1, test 2. Now find voltage across E. Voltage across E. As you know, voltage across E1 and E2 is same. So again, it will be V is equal to E2 minus I2 R2. Again, find out what is I2. So I2 R2 will be equal to E2 minus B. So from this, I2 will be E2 minus B upon R2. So mark this as equation 6. Mark this as equation. Substitute equation 2 and 3 in 1. Substitute equation 2 and 3 in 1. Substitute equation 2 and 3 in 1. Okay, so I1 and I2, whatever you have got, substituting. So it will be I is equal to I1 is what? E1 minus B upon R1 plus I2 E2 minus B upon R2. What I'll do is I'll split the denominator. Split the denominator. So I will be E1 by R1 minus B by R1 plus E2 by R2 minus B by R2. Next, what I'll do, I'll take E terms together and B terms together. E terms together and B terms together. So I will be equal to E1 upon R1 plus E2 upon R2 minus V upon R1 minus V upon R2. I can take V common now or minus V common. So minus V 1 upon R1 minus into plus will be minus. So plus 1 upon R2. 1 upon R2. Calculations much third asa tanga. Have to rub the board in between. Okay. Now basically what we want the equation in this form because हमका जो value find out करना है. Or we want something like B is equal to E equivalent is minus I R equivalent. But we want B to be on one side and E and I are equivalent terms on the other side. So look at, we have B here. So we want B on one side and all other terms on the other side. So the term with B you take on one side. So this I'll take this side. So it will be B 1 upon R1 plus 1 by R2 is equal to E upon R1 plus E2 upon R2 minus this I have taken because I want the term in this particular. So B I want on one side. So B direct hadpa shakna B barabar hot term asa. So entire term I have taken here and this side it is this minus R. I know these derivations are bit not complicated as such, but efforts lagta. If you practice them, it will be easy. They are not as simple as your capacitors in series, capacitors in parallel, those derivations. And don't expect that in physics you will get everything that will be things which are difficult. Okay, I'll just rub this. Now, I just want only V on one side. I want all the terms on the other side. Correct? So what I do is, first I'll cross multiply this. So I'll get V cross multiply this. So it will be R2 plus R1 upon R1 R2 cross multiply. So R2 plus R1 upon denominator plus R1 into R2. Similarly, I will cross multiply this as well. So this will be equal to E1 R2 plus E2 R1 upon R1 R2 minus R minus R. Now, as I want only B on one side, so I'll keep only B here and for term denominator. Whatever is there with B will come to the denominator on the other side because I have to take it on the other. So B will be equal to E1 R2 plus E2 R1 upon R1 R2 upon this term first R2 plus R1 upon R1 R2 minus I upon again it will come to the denominator. I'm doing simple mathematics now. Nothing from physics here. This is all your mathematics. So R2 plus R1 upon R1 R2. So this will get cancelled out. So what will remain? B is equal to E1 R2 plus E2 R1 upon R1 plus R2 minus, now see, denominator of denominator can be written as the numerator. So I can write it as R1 R2 upon R1 plus R2. So for term, I can take it out. Correct? Now try to compare. Now try to compare this equation with this one. You have V here, you have V here, you have some term here, you have E equivalent here. So I can say E equivalent is equal to E1 R2 plus E2 R1 upon R1 plus R2. So whenever the cells are connected in parallel, okay, how to find the E equivalent? This is the formula. E1 into R2 plus E2 into R1 upon R1 plus R2. Next, we can see a negative sign, We can see I, and then we can see this term, and we can see this. So from that we know R equivalent is equal to R1 R2 upon R1 plus R2. So this is the equation to find out. What is that? Equivalent EMF and equivalent internal resistance when cells are connected in parallel. In series, you just add them up. Kitli cells dila, kitli resistors dila, you just add them. In parallel, you have to solve it. Okay. Now, one change here. Suppose पहिली आमका figure दिलो तो असा this was E1, this was E2. Positive were connected together. Correct? Now, if it is changed and if negative of this is connected to positive of this, also suppose figure dila. Negative of this is connected to positive and positive is connected to negative, then the same equation will become E1 minus R2 minus E2 R1 upon R1 plus R2. This will remain fixed. So, fक्त negative sign. Suppose polarity of the equation is fixed. Polarity of the cell is fixed. Just write down one point. Maximum current can be drawn from parallel combination. Maximum current can be drawn from parallel combination if if external resistance, if external resistance is small as compared to net internal resistance of the cell, as compared to net internal resistance of the cell. I'll repeat again. Maximum current can be drawn from parallel combination if external resistance is small as compared to net internal resistance of the cell. So for series combination, current maximum असपा जाय जाल्यार external resistance had to be greater than R equivalent. But in parallel combination, if current has to be maximum, then external resistance has to be smaller than R equivalent. Okay. What I'll do is I'll end the class here because today I think so there is network problem for many of the students. There are hardly any students who have attended the class today. So understanding this situation, I will just end up the class today. So I'll just take the attendance and then we'll